Hello everyone. You may often come across Sudoku puzzle in various areas like newspapers, magazines, and some of the restaurants we will be provided with Sudoku for time passing purposes. Many of us would be in a confused status for solving the puzzle. Here is an easy way of solving Sudoku puzzle using graph coloring. Sudoku, originally called number place, is a logic-based combinatorial number placement puzzle. In classic Sudoku, the objective is to fill a 9 by 9 grid with digits so that each column, each row and each of the 9 3 by 3 subgrids contains all of the digits from 1 to 9. Sometimes the puzzle setter provides a partially completed grid for which a well-posed puzzle has a single solution. Before going into the solution part, we would understand the basic ideas of graph coloring. Graph coloring is one of the most important concepts in graph theory, which is a branch of discrete mathematics and is used in many real-time applications in various fields. These are the contents we are going to deal with in this video. In general, graph G consists of two things. Number one, the vertex set V, whose elements are called vertices or nodes. Number two, the edge set E, connecting a pair of vertices. The vertex set is a point at which two rays of an angle or two edges of the polygon meet. An edge is a line at which vertices are connected in the graph. Edges are denoted by E. It's a pair of two vertices. An undirected graph is one in which edges have no orientation. The edge A, B is identical to the edge B, A. That is, they are not ordered pairs. In a graph G, two vertices are said to be adjacent if there exists an edge between those two vertices. Now, various coloring methods are available like vertex coloring, edge coloring and map coloring, which can be used on requirement basis. An assignment of colors to the vertices of the graph G so that no two adjacent vertices of G have the same color is called vertex coloring of a graph G. The proper coloring of a graph is the coloring of the vertices with minimum number of colors such that no two adjacent vertices receives the same color. The minimum number of colors required for the coloring of graph G is called chromatic number of the graph G. Now we are moving to the solution for a classical Sudoku puzzle. For convenience, we can take 4 by 4 grid Sudoku puzzle for easy understanding. You may come across the problem like this. Fill in the blank cells so that each row, each column and 2 by 2 box has the characters 1 to 4 exactly once. Here there are 16 cells in the grid. Label the cells from 1 to 16 as this. To convert this problem into a graph, plot 16 vertices with each vertex corresponding to a cell in the grid. We need to draw the edges now. How can we draw the edges? We have to see the adjacency relationship. If we give one number from 1 to 4 in one of the cells, we cannot give the same number in the corresponding row, the corresponding column and in the corresponding subgrid. So, two distinct vertices will be adjacent if and only if the corresponding cells in the grid are either in the same row or same column or in the same subgrid. Now, the vertex 1 is adjacent to 2, 3, 4, 5, 9, 13 and 6. Continuing in this manner, we will get the connected graph as this. Now, we have to color the graph properly. That is, minimum number of colors can be used to color the vertices of the graph so that no two adjacent vertices have the same color as this. The minimum number of colors used in this graph is 4 and therefore the chromatic number of this graph is 4. Color the cells as in the corresponding color of the vertex in the graph. Now we assign the digit 1 wherever the cell has the color red. Number 2 in blue colored cell. Number 3 in yellow colored cell. And number 4 in black cells. Each completed Sudoku square then corresponds to a K coloring of the graph. Now we are moving to find the solution to the partially completed well-posed 4x4 Sudoku problem. Here the digit 1 is already assigned in the third row and fifth column. Second is assigned in the third row and the third column. Number 3 is assigned in the second row and second column. So to convert this problem into the graph, plot 16 vertices corresponding to the cells of the grid. Now we need to draw the edges between the vertices. Taking the digit 1, that is 3-1th cell, as the 3-1th vertex in the graph, and it is joined to the vertices 1-1, 2-1, 4-1, 3-2, 3-4, 3-3 and 4-2. Here is the graph corresponding to the Sudoku task. The whole algorithm can be divided into the following steps. Step 1. The vertex that is already colored is selected and linked by edges of the same color with all other vertices of sets in which the vertex is located. These vertices can no longer be colored with the same color. This is repeated for all the vertices. The vertices where the largest number of colored edges converge or found is the second step. The third step, if there are vertices among them that can be colored only by one color, then they are colored with it and the procedure continues from the first step. If there are no such vertices, the procedure continues with the fourth step. Step 4. From the set of those selected vertices, the one that is adjacent to the largest number of uncolored vertices is chosen and the colored to the color with the lowest value that is not used for its neighbors. If there are more such vertices, one of them is selected randomly. In the next step, the procedure continues from the first step. Now color the cells as in the corresponding color of the vertex in the graph. Now we assign the digit 1 whenever the graph has the color black, number 2 in red colored cell, number 3 in green colored cell, and number 4 in blue cells. So this video will be helpful for solving the Sudoku problem by using graph coloring in an easy way. Thanks for watching.